Okay, welcome back. In this video, we're going to keep going with our integer review. In the last video, I went over adding and subtracting. In this video, I'm just going to talk about multiplying and dividing. So the first thing to know about multiplying integers is there are lots of different ways to write it. So I'll just start with two positive numbers, something we're familiar with. Probably when you first started with math, you might have seen it written like this, 3 times 7. Okay, we know that's 21. Sometimes you'll also see a dot instead of an x to mean multiply. When we get into algebra, it can be confusing if we have x's to mean multiply and x's to mean the variable x. So sometimes you see a dot. Sometimes you just won't see an operation at all, and the assumption is multiply. So this also means 3 times 7 is 21, and 3 times 7 is 21. So the first thing to note is there's lots of different ways to write multiplication. This may have been more common in elementary school, and then as you move through math, definitely the latter ones or the bottom ones are going to become more common. The next thing that's kind of useful to know about multiplication is it's what's called commutative. So 3 times 7 is 21. It doesn't matter if I reverse those. So 7 times 3 is also 21. So this is a property that's true about multiplication. It's also true about addition. It doesn't matter what order I add numbers in, I'm going to get the same answer. It turns out that's not true about division and subtraction. I'll just show you quickly a counterexample. So why isn't it true? Well, 8 divided by 4 is 2, but 4 divided by 8 is 0.5. So division and subtraction do not have that same commutative property that multiplication and addition do. So that's one thing to know about multiplication. So we're going to move into talking about integers, so multiplying positives and negatives. The first one we've already done. A positive times a positive is going to be a positive. So I've got 3 groups of 5 objects, whatever they are. I've got 15. So that's no problem. The second one, if I have a negative and a positive, that's going to be a negative. So if I owe $4 to 6 different people, I'm going to owe a total of negative 24. So a negative times a positive has to be a negative. And again, because of that commutative property of multiplication, 4 times negative 6 is negative 24. And then the same thing, if I flip it, I'm going to get the same answer. So we can add to our rule that it doesn't matter what order these are in, a negative times a positive or a positive times a negative, my answer is still going to be negative. So one way to remember that is different signs will always give me a negative. The last one is kind of the strangest from an intuition perspective. But if I have 2 negative numbers, they're always going to multiply to a positive. So I'll just give you an example, and then we're going to talk about it. If I've got negative 9 times negative 11, negative times a negative is a positive, and then 9 times 11 is 99. So my answer is positive 99. So why is that the case? It's a little bit strange to think about. You can think about me. This is why I'm a math teacher, not an art teacher. I go to Tim Hortons every day. I guess Tim Hortons does not give me a mug with one of these. They just give me a cup. I go to Tim Hortons on my way to Beale, and I spend, round into the nearest dollar. I think my coffee is $1.85, so I think I spend $2. Let's round it. So I spend $2 every day. You can think about that. I'm losing $2. So it's negative $2 every day. And then in the course of the week, there's 5 school days, so I'm losing $10, right? So we know that negative times positive, so I'm losing $10. We can think about double negatives or 2 negatives as what happens, COVID comes, now I'm working from home, or March break. Maybe that example is going to age better with time, hopefully. Now what happened is I'm not going to Tim Hortons 5 days a week, so I'm not going to lose money. So it's kind of a double negative, which of course equals a positive. So that's, one example to kind of think about why this is the case. So that's kind of our rule for multiplication. The rule for division is the exact same because multiply and division are its inverse or opposite operations. So multiplying and divide works the same way. We don't need to think of a number line. We just need to remember these rules. If the signs are the same, it multiplies to a positive. If the signs are different, it multiplies to a negative. Why don't we just look at a couple more examples? I'll get a fresh sheet of paper and kind of show you my strategy for doing these questions. So for example, if I have positive 7 multiplied by negative 12, I do these almost in 2 steps. In my first step, I just want to find the magnitude. So I don't care about the sign. I just want to do 7 times 12. I know that's 84. Now I've got different signs, so my answer is negative. So I'm almost looking at the sign and the magnitude as two different parts of the question. Division's the same way. If I've got, 105, let's say negative 105 divided by negative 15. Well, first I say, okay, negative divided by negative, it has to be positive. And then separately, I can do 105 divided by 15 is 7. So my answer is positive 7. So I like to kind of think of them as two separate questions. The first part of the question is figuring out the sign, and the second part is just multiplying or dividing, which we're pros at, and that's just finding what we call the magnitude. How big is our answer, irrespective of sign. The last thing maybe we'll talk about in this video is what happens when I'm multiplying or dividing more than two numbers. So you think about negative 3 times negative 4 times negative 5. Well, negative times negative, so that's going to be positive 12. And then I've still got to multiply it by negative 5. Positive times a negative, so my answer is negative 60. So if I've got 3 negatives, my answer is going to be negative. And I've got an odd number. So you kind of think about each pair of negatives is canceling out. But then if it's an odd number of negatives, I've still got one left over that's going to flip my sign to negative. So it turns out that if I've got an odd number of negatives, my answer to multiplication division is always going to be negative. But if it's an even number, then each pair of negatives is going to turn into a positive, and so my final answer is positive. So again, if I'm multiplying a bunch of numbers in succession, so I don't know, 7 times negative 4 times negative 3 times 2. And let's, sure. So the first thing I'm going to do is I'm going to count the negative signs. I've got 1, 2 negative signs. That's even, so my answer is going to be positive. And then I can multiply the numbers. So again, I can find that magnitude separately. 7 times 4 is 28. 28 times 3 is 84 times 2, so my magnitude is 168. So again, you can just count the number of negatives to figure out the sign and then do the multiplication to find my magnitude or to find my number. So now that we can multiply, divide, add, and subtract integers, you're ready for problems that involve order of operations. And we can just kind of talk about maybe a couple different things. So oftentimes we'll start seeing brackets inside of other brackets. Sometimes you'll see them written as the round brackets on the inside and the square on the outside. Other times you'll just see sets of round brackets kind of coming from inside to outside. So either one is fine in math. So in order of operations, to do what's in the brackets first. Here I've got multiplication, and then I've got some subtraction. So I've got to do my subtraction first. My multiplication first. 7 times negative 5 is negative 35. And then I'm taking away 7, and that's still in my brackets. Then I can work on what's in the other square brackets. Well, that's negative times a negative. So that's going to be a positive 4. What's negative 35? Take away negative 7. Well, that's going to give me negative 42. It's going to be even more negative. Because again, I need to do whatever in the brackets before I divide. So I've got to divide 42 by 4. Negative divides positive, so my answer is going to be negative. And then it's going to be 42 over 4. I tried to make up a question that wouldn't give us a decimal, but I was doing it too quickly or too much pressure on the video. So you could either write that, as 21 over 2, or, if I don't specify, I like fractions more, but we could also leave that as negative 10.5, depending on what type of question that we were doing. So just be careful of interpreting your brackets, be careful of your order of operations, and then you'll be all set to do our practice problems with adding, subtracting, dividing, and multiplying integers. The other thing I want to note, just a communication note, is that when I'm simplifying expressions, I want to start each line or each step with an equal sign. In math, we always want to work vertically down a page and not horizontally across. So I only want to have one step or one expression per line. And what the equal signs tell us is this answer is equivalent to what's above, or is equal to what's above, or is equal to the original question. So whenever we're working on simplifying expressions or working through algebra, we're always going to use one equal sign per line and kind of work down our pages vertically. Okay, that's all for now, and thanks for watching.